Right. So thank you for the introduction. It's really wonderful to have the privilege of being able to lecture here today. So today I will present an overview of 15 years of work in robotics, in computational architecture, both in the context of my work as a CTO at Aectual, as a co-founder of Odeco Formwork Robotics, as also a founder of Easy City in architecture and design research. So to start with the latter, actually I started my PhD work back in 2009 here at the Hyperbody Research Group, led by Cas Oostserre, to further develop or continue this work on evolutionary design, on a generative design process that really mimics Darwinism. So this is a project of Easy City Architecture and Design Research back from 2004, and it really explores at some level what the architectural potential of raw massive computational power is. So we wanted to explore diversity at an industrial scale, right? So this day and age, there is absolutely no need to create standards, right? To create a standard chair. But how do you, in a meaningful way, produce difference? So how can you produce at an industrial scale instances of a single design concept? So we utilized evolutionary computing to generate a large series of these kind of chairs. So evolutionary computing is a numerical optimization technique, which you can think of as Darwinism, so applying the idea of survival of the fittest to design. Those criteria, those fitness criteria, are minimizing the volume required such that the forces that are projected onto such a chair are dissolved, but without any assumptions or abstractions about what such a structure would look like. So here you see the evolutionary process unfolding, and what's interesting is that this process ran on the grid computers, the massively parallel computers at the INRIA facilities. So about 250 very powerful server computers ran for 3 months to generate these series of designs. But another aspect is that the code to fabricate such chairs are an integral delivery of the project, right? So after the evolutionary trajectory has been completed, you are left also with the G code to produce these chairs using a water jet or a milling router. And actually that project is still quite relevant. It was last year in display at the Centre Pompidou, and it also it's also featured in the current issue of Architectural Design, edited by Gilles Retsin, which is called Discrete Reappraising the Digital in Architecture. And I think it's fair to say that the project inspired some of the ongoing research at the Bartlett in discrete geometry and assemblies. On a similar note, we utilized the idea of evolutionary computing in a design competition our office won. Unfortunately, this project has gone unrealized. So evolutionary computing was utilized to find a gallery such that throughout the whole year, throughout the whole day, the gallery can be lit through natural daylight, which is not so obvious, because imagine what happens if if the sun rays directly hit the paintings or the photographies, they would just dissolve before your eyes, right? So, and what's interesting I find with evolutionary computing is that it allows you to kick in open doors, so to say, right? So, in a sense, to design with lights seems such an absolutely cliche and corny idea, but when you have this very potent new tools, you can explore it at a radically higher resolution. So in a sense, it strikes you as an absurd question to ask an architect, hey, design me a window of 300 lux. But actually it's also a totally realistic question to ask. And through tools like evolutionary algorithm, we're able to address these kind of problems in far greater detail. The thing is that this project was both a high and a low, in the sense that we won the project, but unfortunately could not build it. And that gave that resulted in an uncomfortable sense, right? Is that even if you feel like in Olympic form, that you have little control of whether a project will be realized or no. So only 500 meters away from the competition site, I visit this house built by Jean Prouvé, a French architect who developed a method of construction using sheet metal and who ran his own factory. So the industrial quality of the work of Prouvé confronted me also with how alienated architecture had become from being involved in materializing designs. And this image of Prouvé in the autumn of his life, it really strikes me. So he's sitting in a chair that is still being produced by Vritra, and that is quite famous. And actually all the elements that you see are leftovers of his factory. So this man is sitting comfortable in his autonomy. And I think this is something worth striving for. So in 2009, I had the chance to start my PhD research at Hyperbody Research Group, and I still felt haunted by the image of Prouvé, since the famous hospital, the Erasmus Hospital in Rotterdam. All of the facades were built by Prouvé. So Prouvé also instilled the idea with me: can an architect deliver a product? Can an architect run a factory? And back in the day when I was still working with Philippe Morel and Félix Agit under the flag of EasyCity in Paris, somebody who reminded us of this idea was Bernard Cache, who ran a practice called Objectil with Patrick Bosset. And mind you that so in the early 2000s, at the late 90s, there was this idea that an architect can only be a decent architect if he is almost like a philosopher, right? That he has a great grasp of philosophy. And Bernard Cache, the interesting with him was that he sparked this idea of philosophy by other means, seeing architecture as a philosophy by other means. And he was the only architect that inspired great philosophers like Deleuze. So this, to me, that was a very striking thing, because also Bernard Cache had this ambition of running his own factory and producing these kind of products. So working in around 2009, around 2010, I also realized that I knew little in terms of fabrication and how to materialize objects. So I started a series of designs that have been displayed at the Vivid Gallery in Rotterdam. And increasingly, I realized that design and technology are interwoven. So at the pinnacle of the Renaissance, the Duomo in Florence offers insight. So to realize the project, the largest spanning brick dome ever built, Brunelleschi had to devise a new type of hoist. Existing technologies would not allow him to lift great weights, and small weights only very, very slowly. So this frustrated progress. So he introduced a gear mechanism in the hoist to overcome these problems, where the gear mechanism could change direction such that the oxen could keep moving in the same direction. Now the point being is that we can't think of Brunelleschi as merely the designer of the project. He took a very central role in overcoming the many challenges faced when the Duomo was being built. And that bridges into a realization is that perhaps the generation of architects before us were so focused on, let's say, the subjective aspects of architecture, its aesthetics, its underpinning concepts, that a lot of the more objective aspects of architecture, engineering, construction, fabrication, materialization, were left over to engineer, were sort of thrown over the fence at some point. And the diminishing of these, the fact that increasingly addressing these more objective aspects of architecture were not dealt with, I think is generated also a problematic position. Because if you focus on the subjective, over time the architect becomes a stylist and has little to do with the economy of building. So back to the 21st century, it's straightforward to realize what are the oxen of our time. So eager to explore this central role, I set out to buy a number of retired industrial robots here at the Opel plant that was shutting down in Antwerp. So back in those days, the economy took a downfall. So actually, there was a big volume of these robots available for more explorative research. So these robots were shipped to Rotterdam, where I was able to set up a robotics lab. These are a number of 24-year-old robots in the harbor of Rotterdam. So this lab is part of my PhD research. And the first project that was built is this vault spanning over 10 meters. So working with Sylvan Oostserre and Matthias Riepman, the author of Rhinovolt, participated in this project. Rhinovolt is a kind of structural form-finding software, such that the design is only subjected to compressive forces. Now, this small pavilion was built out of polystyrene, out of EPS, which can only deal with compressive forces. And the thing is that it had quite an impact on my thinking about architecture, in the sense that is architecture not a very simple function of capital? Somebody entrusts you with a building budget, capital, labor, materials, and it's your job to maximize the discrepancy between the value of the realized pavilion or house or the realized development and the costs that were involved. And what's a little bit uncomfortable is that to speak about capital seems a little bit of a daring, the elephant in the room at some point, right? And actually it's, I think, quite a neutral terminology, right? Whether your political inclinations are from the right or the left. I think that is not so relevant. So the interesting thing is that with these robots, you learn to speak the parlor of the industry. So experiments that take place on this platform can be easily scaled up to an industrial level, since there's no handing over from one platform to the other. You speak the same dialect, so to say. So to elaborate on this idea of economy, a cubic meter of foam costs about 50 euros, right? So it's used as a foundational layer for highways. So it's really, as a building material, quite dirt cheap, you could say. So I was really interested in creating this tension between the modest costs involved to realize such a pavilion versus its worth. So it took about a week to design this pavilion, a week to cut it, and a week to assemble it. But given traditional CNC machines, producing such a foam element would take about half a day, maybe. So it's prohibitively expensive. With the robot hot wire cutter, it took about 10 minutes to do so, right? So, and I think that sort of hooks back to Brunelleschi. You can think of the development of such fabrication techniques as design at a more abstract level. So it allows you to explore a set of possibilities. It opens up a set of possibilities. And I think if you have a prior understanding to what it might unlock, such a technology, that it's also very much a form of design at a somewhat more abstract level. You also see here how the joint faces of the elements make up the vault, and these are normal to the thrust vectors. In the end, I think there was also a bit of an ambivalence in the materialization of this project. So it was a bit uncertain if you're looking at a mock-up of a pavilion or the thing itself, right? Especially when you sort of knocked on these components, it felt a bit hollow and a bit lightweight. So my analysis was both powerful and very simple. Let's do it out of marble. Since marble is also a material that can deal with massive compressive forces and with very little tensile forces. And also the parallel of economy is there, right? If you develop a new tool, can you make the archaic notion of building in natural stone again a bit more relevant? And also, I have to give you some good advice. When you visit a marmor quarry, don't wear a black suit. You look like an absolute amateur. So, hold on a second. Oh, here we go. So in the summer of 2013, I set out to Carrara with a bunch of friends to explore quite a powerful, fun tool, which is a diamond wire cutter. So rather than using a hot wire to cinch away the material, a incredibly powerful diamond wire is utilized to cut, to chuck through the material. The interesting thing with diamond wires is that they're both the state of the art in material research and both incredibly crude. And I think that is sort of the beauty of this project, right? At some point it's very sophisticated, and at some point it's also incredibly brutal, which I find appealing. So the project is kind of pleasantly equivocal in the sense that conservative architects are like, ooh, natural stone, yeah. And then the progressive people are, ooh, robots. So it seems that everybody liked this project at some point, maybe for those reasons. So this is sped up a little bit. I think this took about 14 minutes. But normally I think this could take about 4 days with a water jet, right? So you just wouldn't even attempt it. And lastly, an interesting idea is that I never even set a chisel into a block of marble, right? And here comes this arrogant kid with his robot to the heart of the marble processing industry, right? With his little robot, and you can make a contribution, right? And that's kind of an interesting idea that can take place now, I think, right? 10 years from now, the possibilities of robotics will be much more explored. So it's quite an uncharted. There is quite an uncharted set of possibilities that are to be explored at this point, and I encourage you to take place in this exploration. I think it's very interesting. So what's cool is that now if you visit the famous Carrara quarry, where Michelangelo sourced the materials for his famous David, you're more likely to see this technology in action, working your way to the quarry. You see it here chugging through a block of 60 tons of concrete. Yeah. This is an image of the architect in the year 2000. In Dutch you would say, misschien heb ik mijn steentje bijgedragen. Now here's a quote from Frank Lloyd Wright, and this is a wonderful book, his autobiography. If I was to realize new buildings, I should have to have new technique. I should have to design buildings that they would not only be appropriate to materials, but design them so that the machine that would have to make them could make them surpassingly well. So again, this quote underscores that developing a fabrication technique is a more abstract form of designing. So I'm really fascinated by the field of stereotomy, which is how you describe a three-dimensional volume in two-dimensional drawings. And this art goes back to the 16th century. I guess the most well-known example is the Trombe of Philibert Delorme in Lille, which is really developing on the advances in projective geometry by Monge. So the math to describe these surfaces was only 15 years old before it was utilized in architecture, which I think is wonderful. And you have to look at this image from a historic perspective, right? Before this Trombe by Philibert Delorme, you had the vertical, the horizontal, but this surface emerging from the vertical and going to an in-between state was never seen before, in a sense. It was absolutely unique. And I think working on my research in hot wire cutting, I also delved into this progressive tradition of stereotomy. So, for instance, here I dealt with the problem of dividing a surface in such a way that it makes sense for a wire cutter. If you just create offsets, you see that, in fact, there's it's quite problematic, right? Just if you observe the picture, it's not self-evident how to produce it. The way I rationalized this was to think of what is an axis. So the axis of a sphere is a point. The axis of a cylinder is a line. But the axis of such a surface is not so self-evident, right? So the yellow line that you see here is the axis of that surface, right? It's the maximum distance from the border of the surface. So when you start pushing contours from this topological skeleton, you are guaranteed never to have any overlaps, right? And you could say, this is pure maths, this is pure geometry. But actually here the maths and the geometry and the geometric analysis also pinch into the fabrication, right? So is this rationalization, is this design? I think it's all of those things. So later on I explored this idea of this isogeometric analysis in a small pavilion, and you still see the medial axis from which these elements are emanating. And the thing is that it was produced in a very, very rapid time, in very little time. So the quality of the cutting was only so-so. Therefore you see the seam between the blocks quite well. But because the segmentation is so beautiful, it still looks good, I think. And I think that is essentially architectural idea in a sense, right? So today, it's not more an oxymoronic thing to say that you want to be a theoretic practitioner or practical theoretician. It's absolutely possible to do these things, right? So Alberti on the left, he spent his life to be an architect removed from the building site, while Brunelleschi spent his life on the building site realizing the Duomo. And I think, hold on a second. I think we no longer need to make a choice between these dialectical models. So shortly after the completion of the Volt in Rotterdam, I met Asbjørn Sundergaard in London at the Fabricate conference. He built this stunning pavilion, a design that was informed through topology optimization. As a result, the structure utilized about only 40% of the usual volume to create such a structure. And Asbjørn, however, used robotic milling technology, which doesn't really scale to an architectural dimension. And this really became an issue already at this small scale of a pavilion. So at this conference, you see Asbjørn's robot milling away at the right. And on the left, my lab. So we could compare notes at some point. And at that point I realized that hot wire cutting could be 10 to 100 times faster than traditional means. So we set out to work on a project together where we interpreted a topologically optimized design by means of hyperbolic paraboloid surfaces, such that it can be easily approximated with ruled surfaces. So this project was recently completed, and a bit of an irony is that while we're working on this academic project, We also set up a startup called Odico Formwork Robotics. I developed a lot of software while doing so, because the process is so incredibly fast. It's 10 to 100 times faster than milling, for instance, that you also need software that programs the robot 10 to 100 times faster. So that was also the scope of my PhD work. So the irony is that before completing this pavilion, the company already made an IPO in Copenhagen, and an initial public offering, beursgang, so to say. On a similar note, my friend Philippe Morel from Easy City set up a company called X3. Oh crap. So you see, damn. Sorry. Technical issues. So X3 specializes in concrete printing, and I think they're still very much state of the art. Oh, this is becoming a joke, no? Also, you see our chair there in the middle. This was at the Meta Utopia exposition at the ZA Gallery, I think about 2 years ago. Also with the work of many of the UCL students. Also, I taught a course at the Bartlett University for some time, where we explored this idea of Thomas Edison, a patent by Thomas Edison actually. So Thomas Edison, well known of the light, the inventor, or acclaimed inventor of the light bulb, for sure, also had a concrete factory, and he built these houses, bunkers actually, completely out of concrete. So you had these cast iron molds in which the concrete was cast in. But all the ornamentation, the details, the bathtubs, tables were an integral part of these molds. So you cast a complete house in one go, which is such a radical idea, no? It's unbelievable. In the end, it didn't work out that well. For a couple of reasons. It takes about a month to cure the concrete, right? These molds were incredibly expensive, and with setting up and taking down the molds, the yield of the investment was only so-so. But mind you is that these were also the early days of concrete, and the concrete that we can utilize today cannot be compared to the concrete of Edison's age. And I think this project, the House 36 by Matthias Bauer Associates, it really underscores this. So when you think of minimalist architecture, it's such a massive contradiction, right? Is that it's an incredible artisanal project to come up with minimalist architecture, since the labor, the craftsmanship involved to hide away all of the details is incredibly expensive, right? So from a capitalist view of economic view of architecture, this seems so contradictory, right? And I think that the house that Matthias built at some point resolves that contradiction, and he does so by a very technical way. So this house is built in what is called warm beton, or lichtbeton, or cellenbeton, or foam concrete. So it's a very lightweight concrete. Normally concrete weighs about 2.5 tons, as you all know or should know. So this concrete, it weighs from 0.4 ton to 0.8 ton, right? So a quarter of the self-weight of ordinary concrete. And this is because there's all this foam glass is injected in this concrete, right? So it's a kind of aerated concrete. So both structure and insulation are performed by the same material, and therefore, in a sense, it's therefore the detailing required in this building are very, very minimal. Simply, there are no cold bridges, right? Is that you need a window frame also to resolve cold bridges. Here, you just mill a certain detail in the concrete, and then you just slap on a piece of glass and you're done, right? Because the detail has been resolved on a more fundamental way, right? It's an inherent property of the material. So, here we go. This is the work of the ICD in Stuttgart, and they are really pushing the state of the art of what is possible in robotics, in architecture. So here you see two KUKA robots weaving carbon fibers, and a drone is transporting the fiber from one robot to the other. I mean, as a roboticist, my heart is totally glowing when I see this. On the other hand, we are also reminded of this beautiful quote of Vrij Otto. And note that I think a lot of the work of the ICD is also informed or inspired by Vrij Otto, who was based also in Stuttgart. He's stating that the secret, I think, of the future is not doing too much. All architects have a tendency to do too much.
Okay.
So,
I have a question. Can you bring it to an end? Because we are 8 minutes over time, so maybe do one item and then...
yeah, I'll wrap up. So what I find really wonderful is that in this project of Grammatio Köhler, a kind of Dadaist form of robotics is explored. So rather than this incredibly involved project, it's just throwing clay at the correct position, at the right location. And it seems effortless and therefore elegant. On the other hand, on the opposite end of the spectrum, we have projects like the Truffle from Ensemble Studios. So a number of straw bales are put in place, the false work to support the concrete. And then a cow is put to work to demold the building, right? And here again, you see the diamond wire saw, the tool of choice by the truly fatalist, to create this opening in the pavilion. And it should also remind you of the way the Philips pavilion by Corbusier and Xenakis was put together. So here on the right you see also another project of Ensemble Studio. And it reminds me of a quote of Marcus Novak, that elegance is the achievement of maximal effect with minimal effort. And at some point you also get a little bit tired of these robots working so hard, right? It should be a bit more effortless. So the question, and I think this is a question that we can pose ourselves in this time frame. I mean, the question will be resolved in a couple of years from now, is that who's the king of automation, right? I think both ends of the spectrum are completely valid. The fatalist kind of approach of Ensemble Studio and the virtuosity in robotics by ICD. And I honestly love both approaches similarly, and they need to be fused. So if I need to sum up this lecture in a final beautiful citation, this one of Claude Nicolas Ledoux, the royal architect of the architect of the ancien regime, is that it is for the architect to oversee the principle. He can activate the resources of industry, husband its products, and avoid costly upkeep. He can augment the treasury by means of the prodigal devices of art. So what's interesting of this quote is that Ledoux is fusing notions of economy and notions of aesthetics, of architecture together. He doesn't make the distinction between one or the other. And I think that is an incredibly relevant and pressing perspective, since robotics really allow us to explore this frame. And the time slot to do so is limited. I think it has to be done now. All right, thanks for your attention.